In this video, we'll look at another worked example with a couple of tricks, especially this trick at the end with the log inequality. And so I'm going to whiz through some of the initial questions. Find the coordinates of the y-intercept. To get a y-intercept, I just let x equals 0. Anything to 0 is 1. That's the answer, but to give it as a coordinate, it would be 0 and 1. Find the value of a. What do I do in any graph when I'm missing a letter? I sub in a point. And so I'm going to sub 2, 9 into this. So the y value is 9. The x value is 2. And when I square root, it's plus minus 3. But I can see that it's going in an upwards direction as opposed to going down here. So therefore, a is just 3. At this point, I personally like to get in the habit of just rewriting the equation. So the gx equation is basically that, in case I need to use it. Like what's happening now. Find the equation of hx, the reflection of g in the y-axis. If you reflect about the y-axis, the x changes. And so it's the same equation. I just change the sign of the x. You could leave it like that, or if you like, a negative power just takes a number to the bottom. And so you could also write your answer like that. Then write down the values of x where 0 is less than log base 3x less than 1. So the one way you could approach this is you could change these other constants into logs. And just to give you a quick theory lesson on that, if I had a number 2, but I was working with a base of 5 and I wanted to know what would the number here be, then the way that I find helpful is you imagine that big number that you have, that constant number, is like the imaginary little power inside there. And so it would be 25. Give you another example. Say I have the number 3 and I'm trying to change it somehow to have a log of 2. Then that number, that constant number, is like the tiny, tiny power of that base. So 2 to the power 3 would be 8. So it would be log 2, 8. And so if I use that logic and I turn these into bases of 3, then it's like this constant number. It's like this 0 is the baby power in there. So it's 3 to the 0 equals 1. And this one would be the power of this little base. So it would be 3 to the 1 is 3. And so there I've changed 0 into a log. I've changed 1 into a log. And therefore, my answer, if I kind of drop all the logs, will just be x is somewhere between 1 and 3, which can be quite helpful. The other way that you can think about it is you could just try visualize the inverse graph, because if here is my original graph, the inverse graph, and this is also a bit of extra theory, I swap the x and the y. So there it is, and if I want y by itself, I must use logs. The base is the base, and it never looks the same. So what's going on here is, where is the inverse graph y value between 0 and 1? And so if I were to draw it really quickly, the y asymptote is 0. So the inverse, it would be the x asymptote is 0. I'm just doing this for extra practice because we have got the answer already. If the y-intercept is 1, now the x-intercept would be 1. If the point was 2, 9, it will now be 9 across and 2 up. And so a really quick inverse graph would look like that. And they're looking where the y value is between 0 and 1. So here the y value is 0. So all I really need is just to have a y value of 1. And this brings the previous video that I did on using inequalities in logs, that it helps to think of this as a point. And so the y value is 1. So if I put 1 back into the inverse here, then it would spit out answer for x of 3. And so where is this between 0 and 1? So here the y is 0, here the y is 1. So where is between there? Between there is happening when the x was 1 and 3. So I should have visually got an answer of somewhere between 1 and 3. This answer that I just did now is a lot more convoluted, but it's good just to explain and show you visually how you can turn inequalities into points, and then from points you can read off what the answer should be. This aspect of the explanation of the video hopefully was helpful, just to show you how you can take normal constant numbers and just think of it as a mini little power to work backwards to help you work out what the big number in the log is, which can be useful at different times. So I hope that you found this video helpful. If you did, please like it, subscribe to our channel, and share it with your friends.